right, so we're going to move on to area formulas, specifically areas of triangles and other quadrilaterals. So we're going to review what area is, and we're going to use some transformations to derive those formulas, to come up with those formulas for ourselves. And then we're going to use that to apply them to solve some problems. All right, so let's just review a little bit of vocab here. We have area, which is a measure of the region enclosed by a figure, right? So area is just what's inside, right? Okay, and remember then that perimeter, now this isn't on here, but remember perimeter is the measure of the outside of that figure, not the inside. So area, we're talking about the inside. And then the base could be any side of a rectangle. Right on this rectangle right here, this we've chosen as the base. But if we flip that over, this could also be the base. Now the important thing is the height, right? So if we've chosen our base, the height must be the side that it is at a 90-degree angle to the base. It's perpendicular to the base. Now that's important, especially when it comes to the formula for our parallelograms and trapezoids and so on. So remember that the height has to be perpendicular. It has to form that 90-degree angle. So we're going to get through this one kind of quickly because you remember the area of a rectangle. We just have our base times our height, right? In other words, if we take base times height, we've just counted all the squares on the inside. So base times height is going to give us the area of our rectangle. And please remember that also when we're talking about area, we want units squared, right? So this one doesn't have a unit of measurement on it, so we're just going to say units squared because we're talking about all of the squares on the inside. We also have two dimensions, right? A base and a height. Well, two dimensions is going to be units squared. There's where our 2 comes in. So if we're talking centimeters, we would say centimeters squared. Now it's going to be important the way you label your answers. Please make sure you use units squared. So like I said, the area formulas for parallelograms, trapezoids, and kites, parallelograms, triangles, and kites, trapezoids should be in here as well, can all be derived from an area, a rectangle's area, base times height. So if we take a look at a parallelogram, this started over here, right? We have a parallelogram with a base and a height. Remember what I said, that height is really important, that it's at a 90-degree angle to the base, right? We're not going to, this is not our height. This diagonal side cannot be our height because it's not at a 90-degree angle to the base. So our height is what goes straight from the top to the bottom to form a 90-degree angle. Right, now how can we get the formula for this, for the area of this parallelogram? So what if I take this triangle on the side and just translate it? So here's our transformation. We're translating that triangle to the other side. Well, all of a sudden it looks like we have a rectangle, again with a base and a height. So our parallelograms formula is going to be the same as a rectangle's formula. The important thing is that you remember that that height has to be straight from top to bottom, not one of the diagonal sides. So the formula when it comes to our parallelogram, area equals, again, base times height. The important thing being where that height is. Please make sure you write down all of these formulas as we go. So we had a rectangle, base times height, parallelogram, again, area equals base times height. Well, let's take a look at a triangle. Now this is a little bit different. It's not a 4-sided figure, it's only a 3-sided figure. Again, notice where I have the height, straight from top to bottom, forming a 90-degree angle. The height is not one of the sides. That is not our height. All right, so how am I going to figure out this formula? Again, we can derive all of the formulas from the area of a rectangle. So how can we turn this into a rectangle? Well, I've just copied this same exact triangle over here, right? So it's the same, again, important that it's the same exact triangle. I'm going to flip that over. So I'm going to rotate that. There's my transformation. I'm rotating my triangle. I'm going to attach it right onto the other one. All right, well, now if I put those two triangles together, again, I have a base wasn't labeled here in the first place, and I have a height, and I have a parallelogram. Well, remember, a parallelogram was area equals, like our rectangle, base times height. So in the figure I have right here, again, my area is base times height because it's a parallelogram. But remember, I just want the area of one of these triangles, not both, right? So if I take away that other triangle, my area becomes just half of my base times my height. So the area formula for a triangle, area equals 1/2 of a parallelogram. So 1/2 of the base times the height. Now I could rewrite that, and some people prefer it this way, equals base times height divided by 2, and that would be the same thing, right? So either one of those formulas is going to work. So there's my triangle. Okay, we have a trapezoid, 2 more. All right, so again, I've gone and just copied my first trapezoid to make an additional trapezoid, and you're going to see why. So in my trapezoid, I have to say that I have 2 bases because the bases are not the same. This base on the bottom is one length, the base on the top is a separate length. So in this case, I actually have base 1 and base 2. And again, my height is my perpendicular distance from the top to the bottom, perpendicular, right? It is not the diagonal side. So how am I going to come up with this formula? Well, again, I'm going to do the same thing I did with my triangle. I'm going to take this trapezoid that I copied, so it's the same exact trapezoid with the same exact area. I'm going to flip that upside down. I'm going to attach it to my other one. So now again, what do I have? I have a parallelogram, 2 pairs of parallel sides, right? And again, remember, a parallelogram, same as a rectangle, is base times height. Well, in this case, remember there are 2 bases, right? So for this one, I actually have to add something to that. I'm going to say my area is both of my bases added together. So my one base of this whole figure is going to be base 1 plus base 2. So instead of just one base, I have base 1 plus base 2. And again, I have this perpendicular height. So for my parallelogram here, this larger figure, I have my base 1 plus base 2 times my height. But one thing's not quite right yet. I'm not finished because I have this really large figure. This is 2 trapezoids, not just one. If I just want to know what one of the trapezoids is, rather than both of them put together, that's only going to be half that figure, right? So I could say base 1 plus base 2 times my height and divide that by 2 just to get one of my trapezoids. You're also going to see that in this way. Actually, I'll just write that down here. So for a trapezoid, I have this whole thing divided by 2, or I could write that as 1/2 instead of divided by 2. So 1/2 of base 1 plus base 2 times my height. So I started with base times height. I had to add those 2 bases together, and then I had to divide it by 2 because I had 2 trapezoids. Finally, a kite. Now, the kite, I'm not going to show you the transformation. We're just going to try to imagine this one. So for a kite, first of all, I have these 2 diagonals, right? I don't really have a base and a height. I have diagonal 1 and I have diagonal 2. But if you notice, diagonal 1, let's see if I can show this. Diagonal 1 right here is the same as my height, right? And then diagonal 2 right here is the same as, scroll down a little bit, it's the same as my base, right? If I just slide this diagonal over, I get my height. If I slide this diagonal down, I get my base. So again, it looks like if I'm looking at this rectangle on the outside, I have area equals base times height, or in this case, diagonal 1 times diagonal 2. Right? Diagonal 2 is the same as my height, diagonal 1 is the same as my base. Not quite finished yet, because what about these pieces? These don't belong in my kite, right? So how do I get rid of these pieces on the outside in order to just get the kite that's on the inside? Well, again, I'm not going to show the transformation here, but if you look at this piece here, it's just the same as this triangle here. So these two triangles are equal. These two triangles are equal. These two triangles are equal. And these two triangles are equal. So again, like in my last one, if I eliminate these pieces, really what I'm doing is just dividing this larger rectangle by 2. And I can write that again instead of divided by 2. You're going to see that most times as 1/2 of diagonal 1 and diagonal 2 times diagonal 2. So there's the area. There's the area of my kite. So I can think of it as this way. Here's my kite in the middle of this rectangle, and this kite takes up half of the area of the rectangle. The area of the rectangle is just base times height, or diagonal 1 times diagonal 2. So to get just half of that, I'm going to divide by 2, or down here multiply by 1/2. All right, so to summarize, let's make sure we have all of our area formulas. So for a parallelogram, we have base times height, just like for our rectangle. We have our triangle, which is just half of a rectangle or half of a parallelogram. So it's going to be 1/2 of the base times the height. For our kite, again, it was half of a rectangle. So instead of base times height, we're just going to call it diagonal 1 and diagonal 2. So 1/2 of diagonal 1 times diagonal 2. And then finally for our trapezoid, which is a little bit longer, our area is going to be half of that larger parallelogram. So 1/2 of, and again, I have 2 bases. So base 1 plus base 2 times my height. Right, so there are my 5 formulas that we need to remember. Just a couple of examples, at least one. So here we have a known area. Area equals 63 inches squared, again, square units. And I want to find out what x is. Well, x looks like my height, right? It's that perpendicular height. So let's remember, and this is a trapezoid. So let's remember what the area of a trapezoid is. So the area of my trapezoid is going to be 1/2 of base 1 plus base 2. I'm going to start, that's base, not height. I'm going to start with my formula to make sure that I'm substituting everything in the correct places. It also helps us remember the formula if we write it down, right, times my height. So now let's substitute what we can substitute. So now area I have, so area is 63 units squared or inches squared, is 1/2 of base 1 plus base 2. Base 1 is 4 inches, base 2 is 10 inches, so I get 1/2 of 14 times my height, which is x. So you have to remember some algebra here. So let's use our order of operations. Simplify the right-hand side, and I have 63 equals 1/2 of 14. 1/2 of 14 is 7, so I have 7x. Finally, to continue solving that, I'm going to undo that 7 by dividing by 7, and I get 9 inches equals x. So my height is 9 inches. All right, one more example. So here we're going to find the area. We're going to skip the perimeter for the moment. Just remember that the perimeter is the outside, right? So I want to add up all those outside pieces. And that's a single dimension, but I'm going to find the area here. Well, this is a composite figure. In other words, I have various shapes put together. So if we focus on one shape at a time, so in other words, if I focus on this parallelogram first, I can find that area and add it to the other. So remember, the area of a parallelogram is just going to be base times height. So in this case, if I use 40 as my base, and my height right here is that perpendicular length. So I have 40 times 28. So my area for that piece, if I take out my calculator, is 40 times 28, which is, oops, I guess you can't see that calculator, which is 1,120 so far centimeters squared. All right, I have one more piece though. I also have this parallelogram over here. So for that second parallelogram, I'm going to have, it looks like a base. My base is down here if you notice. So this is 40 centimeters. So for this one, I have 40 centimeters times my height, in this case, is going to be just 8 centimeters. So in this case, I have 40 times 8. We use some mental math for this one. 4 times 8 is 32. Add a 0, so I have 320 centimeters squared. So to find the area of the entire composite figure, I'm going to go ahead and I'm going to add those. Oh, where'd my calculator go? Here we go. So I'm going to add those together and I'm going to get 1,120 plus 320 is going to give me 1,440 centimeters squared in total.